Hello students, in this video you will find Bohr's atomic model in your chapter Structure of Atom. In 1913, Niels Bohr modified Rutherford's atomic model with the help of Planck's quantum theory of radiation in order to explain the stability of atom. I am going to tell you Bohr's atomic model. Now, Bohr's atomic model. Bohr's atomic model. In this one, first point, according to Bohr's model, first point. Atom consists of a dense, massive, positively charged nucleus at its center and negatively charged electrons revolving around it in a definite, fixed, circular, planar path without radiating energy. These circular paths are called orbits or cells. Next point. Electron revolve. Point number 2 I am telling you. Electron revolve around the nucleus, I told you, in a definite circular path without losing energy. This is why this circular path is also known as stationary state. Stationary state, remember. Third point I am going to tell you. This stationary state, this orbit or cell, is associated with certain definite amount of energy. Therefore, these orbits or cells are also called energy levels or energy cells. Energy levels or energy cells. Fourth point I am going to tell you. These energy cells or energy levels, or you can say orbits or cells, are characterized by an integer. Characterized by an integer n, which is called principal quantum number. N is called principal quantum number, which can have values 1, 2, 3, 4 and so on. Once again, orbit or cell is characterized by an integer n, which can have values 1, 2, 3, 4 and so on, 5 etc. This integer is called principal quantum number. What is called that? Principal quantum number. Principal quantum number. Next point. Orbits or cells are represented by the number n equal to 1, 2, 3, 4, like etc. or by the letter K, L, M, N and so on. Orbits or cells are represented by the number or by the letter. One example. This is a nucleus where protons and neutrons are present, and this is the cell orbit. This is the second orbit or cell. This is third orbit or cell. This is fourth orbit or cell. like that. These are represented by the letter first cell K, L, M, N, like that, and or it is represented by the number N equal to 1, 2, 3, 4, like that. These are the numbers N equal to 1, 2, 3, 4, like that. Here K means first cell, L means second cell, M means third, N means fourth cell, like that. Next point, these cells are numbered from nucleus side to outward, like this. Next point, the energy of the cell increases with the increase in the distance between nucleus and the cell. The cell nearest to the nucleus, that is the first cell, has lowest energy, and the cell farthest from the nucleus has highest energy. With the increase of distance, energy is increasing. This is why first cell is having lowest, this is nearest to the nucleus, and the outermost cell farthest away from the nucleus, that is having highest energy. Next point, when electrons revolve around the nucleus in the lowest energy level, that is called ground state of the atom, having minimum energy, not the first cell always, in the minimum energy state. What is that? That is the ground state of the atom. And as long as an electron revolves around the nucleus in a particular stationary state or orbit, it neither lose nor gain energy. This is why atom is stable. Atom does not collapse according to Bohr's concept. Next point, if an electron jumps from lower energy level to higher energy level, if an electron is here suppose, and it jumps from here to higher energy level, then it absorbs energy from outside. If an electron jumps from lower energy level to higher energy level, then it absorbs energy. And when an electron jumps from higher energy level to lower energy level, comes from higher to lower, then it loses energy. In that case, it will lose energy in the form of radiation. Then an electron will lose energy when it goes from higher energy level to lower energy level. It's jumping from higher to lower. And if an electron jumps from lower to higher, then it absorbs energy. And that coming from lower to higher energy level, after absorbing energy, this is the excited state of the atom. Absorption or emission of energy during electron transition occurs discontinuously in the form of quantum or plural form is quantos and singular form is quantum. Then plural form, quantum are packets of energy, one quantum of energy, one packet of energy. Then absorption or emission, losing energy, takes place in the discontinuously in the form of quantum packet. What is quantum means? Hence, the quantity of energy absorbed or lost is a quantized quantity. Quantized means a quantity which does not vary continuously. Means one quantum, two quantum energy is either absorbed, etc., absorbed or lost. But not 1.1 quantum, 1.2 quantum, not like that. This quantity is a quantized quantity. And Next point, electrons are distributed in the different cell according to some scheme. Electrons are distributed in the orbit according to some scheme proposed by Bohr and Bury. Proposed by Bohr and Bury. That you will get electronic distribution, electronic configuration in the next video. That's all for today. Again, next video I will tell you about the distribution of electron. Thank you.